Hello guys and welcome to my channel. As you know guys, this is one of the series of video that I am doing here on my channel to create a drone right from the scratch for the aerial photography. In this video guys, I am going to do a quick unboxing of this iFlight XING-E Pro motor, and I am going to tell you what are the basics and specifications of the motor, how to select the best motor for your drone, and also towards the end of this video guys, I am going to tell you overview and wiring diagram of how to connect this motor onto your drone. So guys, if you are new to assembling the drone, please ensure that you watch this video till the end so that you do not miss out on any important information or instructions that I have to share. Before we move further guys, if you are new to my channel and not yet subscribed to my channel, please hit that subscribe button and click that bell notification icon so that you get the notifications for all my new videos. Let's get started. So guys, before we can go into the technical specifications and tell you in detail what does that mean and how does it impact the selection of your motor, let's quickly unbox this iFlight motor so that I can tell you what are the technical specification or information which is present on the top of the box, which will help you understand what does that all technical specification means, and then you can make sense out of it. So let's quickly unbox this. So when you buy this iFlight XING-E Pro motor, this comes in this plastic bag. As you can see, this is the set of 4 motors that it comes inside. As I'm going to make a quadcopter guys, so I will be needing all 4 motors. So depending upon the type of drone you're making guys, you'll buy the number of motors that is required by you. So for my quadcopter, 4 is sufficient. On the transparent packing, you can see guys, on the top it says iFlight 4 pieces XING-E Pro 2207 motors. That is what is there on the top of this cover guys, nothing more. Let's open the packing and see the motors inside. So inside, as it was visible from outside, it comes with 4 motors right here in the black boxes. These all 4 motors are identical in nature, so we will review any one of them and quickly see what are the information present on the box. Let's keep the 3 boxes aside. On the box guys, you see this is a XING series advanced power system made by iFlight here on right on the top of the box, and here you can see some of the specification which is present on the top of the box. It says it is a XING-E Pro motor 2207 and 2450 kV. In a minute guys, I'm going to tell you what does that information mean and how does it translate to the power and the torque and the load capacity of these motors and also the RPM. Before that, let's quickly open the box and see the motor inside. When you first open the motor, you can see it comes with the top side foam packing so as to prevent it from damage. So let's remove the foam cover from the top, and then it includes 4 M3 screws. So guys, this motor is M3 screw compatible guys. So if your drone frame that you have purchased does not take M3 screws, it takes M2 screws, you need to buy a different type of motor with different specifications so that the holes which are used to mount this motor onto your drone frame should be matching with the screw requirement of your drone frame. So depending upon the motor and the drone frame guys, ensure that you buy a compatible motor. So this comes with M3 screws, and there is a propeller holder nut which will help you to mount the propeller on the top side of your motor. So this is also included here in this packaging, so let's keep that aside. Now inside the box guys, you can see the motor is nicely packed inside this foam packaging so as to prevent it from any shock or scratches during the transport. So this is also something really nice. Let's take out the motor. As you can see guys, this does not come with any user manual or instruction manual on how to install this motor guys. So I'm going to tell you in this video how to exactly wire this motor and how to install this motor onto your drone. So ensure that guys, you watch this video till the end, and also stay tuned to my channel so that you get the notifications for all my new videos. Let's keep the box aside. Before we can go with the technical specification of this motor, let us look at the physical specification that it came with. So here you can see guys, this is a brushless motor guys, and also this is a 3-phase motor, so it has 3 wires coming out of this motor, which is pretty much standard in these days to be used on any kind of drone that you are building. So here on the motor you can see guys, this is a wide motor and it has a smaller height, and also there is a shaft coming outside from the center of the motor which is really threaded, on which you will be putting on your drone propellers, and then using the drone propeller holder which came here like a nut, you will be tightening this up so that your propeller does not move, and whenever the motor spins, the propeller spins along with this. So this is the shaft which it comes with. On the back side, guys, you really have the base. So the base is going to be fixed, guys, on your drone frame. It comes with the holes, as you can see here, guys. These are M3 holes, guys, which is compatible with my drone frame, whose unboxing and assembly I have already done on my channel. If you have not seen that video, guys, I will put the link of the video above or in the description below for you guys to check it out. As I told you guys, the base is going to be fixed, and since it is a brushless motor, guys, the top side body is going to move, which in turn is going to rotate the shaft as well, as you can see here, guys. The difference between the normal motor and the three-phase motor goes, so normally in a general purpose motor, normally you have two wire, one is positive and negative, but then normally it is not normally marked like that. But then whenever you connect a positive and negative, it rotates in one direction, and then whenever you change the polarity or reverse the polarity from positive to negative in two-wire motor, guys, the direction of the rotation is normally reversed. But here in three-phase motor, guys, there is three wires, guys. It requires a three-phase supply to operate, but to change the direction of the rotation, guys, all you need to do is reverse the connection of any two wires, and the direction of the rotation of the motor will be reversed. In normally, guys, all these flight controllers or your motor control unit is programmable through your flight controller, so you don't need to worry about in the order in which you are going to connect these three wires onto your motor control unit, because normally your flight controller or your configuration of the flight controller will be able to help you change the direction of the rotation of the motor. So it does not really matter in which sequence you put all these three wires and connect it to your motor control unit of your flight controller. So furthermore, guys, you can see here on the print of the motor, it says the branding of XING-E Pro motor. Along with that, it says 2207 and 2450 kV. So guys, now let us see what these specifications mean. There are a lot of factors which impact the performance of a motor, which includes the type of winding, material of winding, thickness of the wire of the winding, strength of the magnet. But guys, these all specifications are not present on the top side of the motor, so it's really difficult to assess the performance or efficiency of this motor depending upon those information which is missing. So I'm going to tell you guys an easier way on how to read this technical specification, what does that mean, and how do you select a different type of motor, and you can compare one motor from another using these technical specification or two numbers basically, which is mentioned right here on the top of the motor or on the top side of the box whenever you purchase the motor for your drones. Now let us look at the technical specification. What does that mean and how do we read these technical specifications? So guys, before we can start with the basics of understanding the technical specifications of the motor, if you are looking for a best motor, guys, it is really not possible to tell you which motor is best and which is the one you should buy. But definitely using these technical specifications, which I am going to explain you right here, you will definitely be able to tell which motor is better than the other motor. So guys, let's go through it and see what those technical specification means. So let us start with how to read the specifications of the motor. So as we saw in the unboxing, the three information normally which is present at the time of purchase of the motor is these three numbers. First one is 2207, another one is 2450 kV, and then 4S. So these are the three information which is normally either present or printed on the top of the box, or it is possibly present on the general information or description of the product. So now let us see what those three information when you read means. So 2207 basically is related to your torque, and 2450 kV is related to your RPM of the motor, which is rounds per minute, or how many round does the motor shaft spins per minute. So that is what it more or less relates to it. It's not directly related, but then I will tell you guys in a minute how does that information translate to the RPM of the motor. And the third information basically translates to the rating of the motor or the power requirement of the motor. So it is the voltage on which it operates. So now let us see one by one what does all these three information means, and how can we basically understand, how can we basically combine these three information to tell you the relative performance of a motor. So first thing is torque. Torque is basically the load capacity or the strength of the motor to be able to lift the load. So what kind of load does a drone normally has? It has its own body weight, all the sensors, your flight controllers, motor, in any other equipment that you mount, like you mount a GoPro or a battery or any other thing that you basically mount on the drone frame, adds to the load of the drone. So basically, higher the torque, higher the capability of the drone to be able to lift that load. So basically, torque is proportional to the volume of the stator. Volume of the stator is basically 2207. 22 is the width of the motor in mm and 07 is the height of the motor. So here you can see 2207, when you multiply, it comes out to be 154. So any stator which has higher volume will basically be better motor, as it will be producing higher torque. But if you see here guys, 2306 is an inferior motor than 2207, because when you multiply 23 by 6, it comes out to be 138, which is lower volume than 154. So 2306 is going to have a lower torque than 2207. So this is how guys you normally compare the torque from one motor to another. So 2207 is basically going to be a higher torque or better performing, not in performance basically, but then higher load bearing capacity than 2306 motor. So that is how you read 2207 and it translates to torque. Second information that you want to know is 4S. 4S is basically your power rating or voltage rating, or basically the battery with which you're going to operate your drone. 1S basically means 4.2 volt. So here 4S basically means 4.2 multiplied by 4, which is 16.8 volt. This is the maximum voltage supplied by the battery, and this is the maximum voltage rating of your motor as well. So guys, if your motor says that it is operating at 4S maximum voltage, please do not run it through 6S or higher voltage, as it will damage your motor coils, as your motor coil rating cannot support higher voltage and it will melt basically due to heat. So ensure that guys, whenever it says your motor rating is 4S, do not use a voltage or battery higher than 4S to operate this motor. The second information which is present on your drone box or printed on your drone frame is printed on your drone motor is 2450 kV. This basically relates to RPM when multiplied by the voltage rating or maximum voltage rating that it supports. So here you can see my motor was rated as 2450 kV and the highest voltage rating that it supported was 4S. So it translates to around 41160 RPM at no load, which means basically when you are not connecting to the propeller and when it is not flying or anything, without any resistance, the normal shaft, when you supply a 4S voltage which is 16.8, is going to rotate the shaft with 41,160 RPM. So as a general rule, higher the RPM, better the performance. I mean, higher speed it rotates, it will have a higher lift capability. But then guys, whenever you connect propeller onto the shaft, definitely your RPM is going to be lower than this one, because it is having a friction from the air, there is a load from the drone. So basically guys, here you see higher the volume, higher the torque, higher the 2450 kV RPM rating, higher the RPM of the motor. So both things are higher is better. But then guys, like everything in the world, there is an exception. So now let us see what are the exceptions. So wider the motor, higher is the inertia. So as you know, since the motor is wider, the load distribution of the body weight of the motor is at larger distance from the motor shaft. So whenever it is rotating, there is an higher inertia. So if there is higher the inertia, when you change the RPM, it will take take some time to change the speed of the shaft because of the inertia of the motor. So you can see if you have a wider motor, it will respond slower to the change in the RPM with the motor which has. So you would say, let's have a smaller width and higher the height. By general rule, I mean that is correct. So slimmer motor with higher height will basically have RPM change response higher than the motor which has wider width and smaller height. But then wider the motor, higher is the surface area and lower is the overheating capability because it has a larger surface area to dissipate the heat. But when you have a shorter width, guys, your motor heat dissipation is lower. So your motor normally gets overheated on a higher torque or higher load because it does not have a capability or surface to dissipate heat. So here you see, guys, if you have a slimmer motor, it has a higher response to the RPM change, but when you have a wider motor, your stability of the motor is higher because it has higher surface area to dissipate the heat. So you see, guys, there is a trade-off between the torque and the heat generation, because heat generation is equally important, guys. If your motor get overheated, it can damage your coil, it will melt your coil, and there are a lot of things can go wrong with the higher heat. So you need to have a balance between the width of the motor and height of the motor so as to have an optimal performance. So the third exception is higher the kV value, higher is the current drawn for a given torque. So guys, higher the kV value, higher is the current drawn for a given torque. What does that mean? So if you have a similar physical specification, let's say you have another motor of 2207 with the same width and the same height with the lower kV, so definitely it will have lower RPM because of the rating is same, your physical specification is same. When you have lower 2450 kV rating for the RPM, you will have a lower RPM, but then it will have a better performance, guys, because at the same torque, maximum torque that it can produce, because which is proportional to the stator volume, it has nothing to do with the RPM, but then lower the 2450 kV value, it will draw lower current from the battery. So anything which is 2207, let's say it has 1700 kV, so it has a better performance because for a given load it will draw lesser current from the battery, so it will have better performance. Your battery will be draining lower, and also your heat generation in the motor will be lower because the current drawn from the motor is also lower. So you see, guys, when higher the RPM, higher the kV value, higher is the drawn current, higher is the discharge from the battery, and higher is the heat generated. So you see, at higher RPM, guys, the motor normally gets hot because it is drawing more current from the battery. So here also you see, with an RPM you have a trade-off. Higher the RPM, then you will have an higher current drawn from the battery to give an equal amount of torque. So whenever you want to compare two different types of motor with same physical specification and rating, you would know that lower the kV value will have a better performance because the load capability or the utilization of the battery is more efficient for a given load in that scenario when you have lower kV value. So the fourth exception you can see here, guys, is lower the RPM, higher is the torque, which is normally true because, as you know, the geared motors normally has higher load bearing capability, but it is normally rotating slow. So slower the motor, it has higher torque and it will take up higher load. But then when motor is running at higher speed, the torque is normally reduced and then your load capability is normally reduced. So normally at full RPM, guys, whenever you report the load capability of a drone, normally you report it at full RPM speed. So that is when when I am running at full throttle, what is the maximum load that I can carry. At the lower RPM, guys, you will definitely have higher torque and you will be able to carry the higher load. But at higher RPM, guys, your load bearing capability goes down as the torque reduces. So as a general thumb of rule, torque to weight ratio can range from 3:1 to 5:1, which is an ideal scenario. So higher the better, and better is the performance of the drone, guys. So as you can see, guys, from this description, Best is a relative term, guys, because you cannot really tell which is the best motor to be used, but you can definitely, using the information which I have shown here on the screen, tell whether one motor is better than another motor. So depending upon the use case, guys, the type of drone that you are building, using this information you will be able to select the drone. Now guys, let's see an overview on how to connect the drone motor onto your ESCs. So here, as a general rule, any drone would normally have an ESC, which is this. This is called your ESC or motor control unit, which basically is connected to your motor. The three-phase motor that you normally have, the three wires coming in, is normally connected onto your ESC, which will then, depending upon your flight condition, will be able to deliver the power to each of the motor and also controls the direction of the motor using the control wires that is coming to this motor control unit from your flight controller. So you will normally have 6 pads on each side for a quadcopter, which will be marked from M1, M2, M3 and M4. So you will be connecting 3 wires for each motor to this motor control unit, and this is how your wiring will go. But then ensure that, guys, you connect these motors in the right sequence, and I'm going to tell you what does that mean. So here you see, when your drone is facing front, your ESC is placed like this. There are motor numbers. You see here motor 1, 2, 3 and 4, which is also marked here on your ESC. Ensure that, guys, your motor 2 is your front side right motor. So here you can see the left and the right direction. The right motor on the front side is M2, right motor on the back side is M1, left motor on the front side is M4, and left motor on the back side is M3. So although, guys, in all modern flight controllers, you can change this sequence, you can change the direction of the rotation of the motor in the program, but if you do this in this way, in the correct way, you will have lesser configuration to do in your flight controller to be able to operate it in a correct. So there is no right and wrong. You can always connect these motors in any sequence as you like, as long as your flight controller has a capability to reorganize the motor and then arrange them in a correct way so that your flight controller knows which motor is connected at which place so that it can properly operate the drone. So guys, this is it. This is how you connect your motor to your ESC, and this is a brief description on how to select the motor and what kind of technical specifications that you have on the motor. So I hope you guys like this video. If you guys like this video, please do not forget to hit that like button. If you have any questions or comment, please leave them in the comment section below. I will try and answer as soon as possible. If you are new to my channel and not yet subscribed to my channel, please hit that subscribe button and click that bell notification icon so that you get the notifications for all my new videos. Thank you guys. Thanks for watching, and clear skies.